From Studio A at the USC Annenberg School, this is Aditi Jain, your host for the Paradigm Podcast. Today, I'm joined by Professor Bistra Dilkina, the Dr. Allen and Charlotte Ginsburg Early Career Chair in Computer Science at USC. She's also the co-director of the Center for AI in Society, a joint initiative between Viterbi School of Engineering and the School of Social Work. CAIS furthers research in education and responsible AI through partnerships with communities and policymakers in areas of environment, homelessness, and health and well-being. Professor Bistra's research lies at the intersection of AI, optimization, and sustainability, tackling large-scale real-world challenges in areas like biodiversity conservation and disaster resilience. Before joining USC, she was a faculty member at Georgia Tech and earned her PhD in computer science from Cornell University. Welcome, Professor Bistra. Hi, Professor Bistra. Before we dive in, could you give a little bit of a background and of your journey and how you became first interested in AI and sustainability?
Yeah, thanks. Happy to be here on this podcast. I guess I've been doing this for a while. My interest in AI started very early on, actually, as a high schooler. I got a chance to be in this research program, summer research program at MIT, where I was interested in math, but I didn't know what AI is. And then I just got matched with a mentor who was doing early NLP. And I was like, oh my God, you can make the computer smart. And so then I went on to study computer science and AI in undergrad and then to do my PhD at Cornell. The interest in sustainability, I guess, just in terms of I've always had a passion for nature, and ever since I was a little kid, my grandma was a biology teacher, and my grandpa was a geography or something like that, and they would always take students in the summers to do mountaineering, and so they would take us along with us. But then during my PhD at Cornell, I got an opportunity to combine those two passions, and so this was started with this big NSF grant that my PhD advisor at Cornell won. It was her name is Carla Gomez, and the grant was part of the National Science Foundation Expeditions in Computing competition, which was supposed to basically award grants that have big visions of how to push the next frontier in computer science. And what she had proposed together with others is to build this new field of computational sustainability. And so what's computational sustainability is really a way to make people in computational sciences excited about bringing their skills to address sustainability challenges. And it came from the realization that, when talking about sustainable development goals, there's many experts in the room from policy, from economics, from biology, ecology, and all these things, but very few computer scientists. And yet our skill set is so relevant, predicting, deciding, optimizing in all of these areas of making a change in sustainable development efforts. And so I just jumped on the opportunity and never looked back.
Yeah, that's a very exciting journey. And so you've been working at the intersection of optimization, AI, and sustainability for almost over a decade now. So in those years, what's one realization that changed how you think about the role of AI in solving environmental or social problems?
Yeah, so one thing that became really clear as I was getting engaged in more of these interdisciplinary projects is the technical skill alone cannot really make these projects succeed. It's really this ability and commitment to work in interdisciplinary teams, having the patience to listen and to understand and educate others about your kind of lingo and approaches and so on. And so it almost is just as important to be a good science communicator as it is to have the algorithmic chops. And so I think if we want to have more people to enter this area and be effective, we really need to kind of couple, even in our education, the skill sets of understanding how to translate, real-world descriptions of problems coming from stakeholders and partners and abstract them to kind of mathematical or computational problems, but then be able to translate that back to the people you're talking to verify that, in fact, your abstraction is not wrong. And so this kind of a back and forth and working closely is super important.
Yeah, and like coming to the point of like educating people, I think this field of AI and like actually applying it was kind of daunting to me. And when I saw your class, I was like, okay, maybe I should put myself out there. I'm interested in AI, but how can I use it? Also, very interested in sustainability. And so, like when I joined your class, the way that you kind of converted your technical concepts of algorithms optimization to like a more understandable terms, I think made it a little bit less daunting. And so I think yeah, being able to converse with people of all backgrounds is very, very important in this field.
Yeah, and I have found over the years as I've taught this class first like under computational sustainability, then AI for social good, and now more AI for sustainable development is that often this class attracts students that are kind of non-traditional computer science majors or people that are in other fields but are really interested in computational approaches as well, but they come in because they have like they're interested in the environment or they're interested in some other sustainability related topic and provides kind of a foot in the door even for these more diverse backgrounds of students and showing them like, yeah, you can bring this interest and then learn the technical concepts and then be able to translate between the two worlds. So it's always really fun to teach it.
Yeah, because for the project that I'm doing, we're also doing sort of like policy simulations and stuff like that on our like model. So I feel like it's not just for kind of CS majors or more technical majors, also like public policy majors or environmental studies. So yeah, that's super cool. And so like throughout your journey, what would you say have been some of your like most fulfilling projects or research areas?
Yeah, I would say, I mean, one of, my, during my PhD years, I guess what really made super excited about to continue on this path was a very close collaboration between our research lab and the U.S. Forest Service, where we were looking at doing conservation planning for wildlife corridors. And so wildlife corridors are this kind of intervention for protection of land that explicitly conserves whole paths of land that connect different established big conservation areas or populations of a species. It's really important to do this when you have this kind of anthropogenic pressures like urbanization and agriculture and deforestation and so on. But it's also very hard computationally. And so working together with the U.S. Forest Service and understanding, their needs, where they were looking at protecting several like threatened species and sensitive species like grizzly bears and wolverine, and thinking about how they can combine efforts across both. And the I guess most rewarding thing about this project is that at the end, with these results that we generated, our collaborators at the U.S. Forest Service were able to bring those results and use them at like a policy level meeting with the Western Governors Association and show like, okay, here is some of the cost benefit analysis of like, if we invest that many dollars in conservation efforts, how much we can benefit the species versus not. And so having that connection between the algorithmic development and solving this really cool, interesting, NP-hard computational problem, but then also turning it around and providing kind of results that they could take to the real world and like talk to politicians about the importance of those things.
Yeah, I think seeing that impact has to be really, really fulfilling. But kind of in general, how would you go about describing AI for sustainable development? Do you think it's about building better algorithms or kind of building better societies, those algorithms?
Yeah, a very, very good question. I think it's both, but obviously it's more focused on the second part, which is you want to be working on problems that are actually a pain point that are needed by the stakeholders and the end users. And I'm very much like a proponent of like really not doing this kind of white tower approach to academics, where it's like, oh, there's this interesting problem that would make people excited, but then you take it and then you just work on it like up in an abstract way and like develop some algorithms and show, hey, here is something, but then you don't apply to the real data or you don't talk back to the people that provided the problem to see, well, is this actually helping them make decisions or do their job better or not? But on the other hand, in my experience, working on AI for sustainable development is a two-way street. a lot of the real world problems that come from these applications require innovation on the CS side. So they require new machine learning techniques, they require new optimization techniques, and so they're like challenging us, our field of computer science, to innovate and push the boundary. So it works in both ways, which is really great.
Yeah, that makes a lot of sense. And kind of from your perspective, what distinguishes AI for social good from traditional AI research?
Yeah, so back to some of the things I said earlier, like the key thing is to really have this commitment to try to understand the needs of the stakeholders and not just kind of taking the data, abstracting away, and just focusing on the technical development, but actually thinking about like, well, once you get these results, how usable and useful are they to the end users you started with? So it focuses a lot on computational techniques, but also this kind of human technology interaction and then being able to translate and be interested in translating these innovations to the last mile, where you put it in the hands of the people that have the problem at hand.
Yeah, that makes a lot of sense. And in these past like couple of years, obviously, the boundaries of AI have been being pushed a lot. So, kind of, if you could describe the evolution of this field in the last 10 years, what would the timeline look like at a very high level?
Well, I guess when computational sustainability started, it was kind of germinated by the fact of that there was so few computer scientists working really in environmental and sustainability problems. So I would say that at the beginning it was quite difficult, especially like as a PhD student, let's say writing papers that are more applied in these application domains that are not familiar to the CS communities. It was really hard to like get papers accepted and or appreciated. But then over the years, like it has really grown, and I would say to some extent exploded in interest, because it, in fact, it generated exactly this like interest of people that otherwise might not even consider computer science as their degree of study, but they bring that like really real passion about the social good problem. So now major conferences like Triple AI and the International Joint Conference on AI, NeurIPS have actually kind of like tracks or like multi-year workshops dedicated on to like publications and research on that. So there's like track on AI for social impact at Triple AI. NeurIPS has the climate change workshop, and they actually have tons of participants and submissions. And so the community is really growing, and also the kind of AI techniques and people across the board from all subfields of AI are crossing into that, from like people that work on computer vision and, for example, using computer vision with satellite imagery to study poverty or study land use or disaster relief, people working on computer vision and combining that with like images taken by cameras that are monitoring species in the wild, and again, pushing the frontier in these fields, to people working on NLP and LLMs and seeing how those can work, to people working more in the decision-making and resource allocation and optimization like me, looking at like planning and in other problems in this space. So like it's really like we've seen this like across the board of different subfields of AI really getting engaged in social impact applications.
That makes sense. And then kind of like, like obviously the big companies now like Meta, OpenAI, slowly Microsoft and big companies like that are really trying to like push the frontiers of AI. How do you think that bleeds into kind of your work and like the AI for social good, or just like in general, what are your thoughts on that space?
Yeah, I mean, AI is having a moment, right?
Yeah.
A big moment, I would say. Like, I would say that 3 or 5 years ago, like the general public's awareness of AI as a term was, not very high, and now suddenly everybody is talking about AI. So, in a sense, that's really good. Both in terms of like awareness, but also the technology is developing. Also, some of the developments in, let's say, in LLMs, I think have a lot of opportunity for just social impact applications in terms of making some of the things more accessible, I would say democratized. Like, for example, if somebody doesn't have access to optimization expert, they might go to one of those LLMs and ask, like, hey, I'm trying to solve this problem. How would I approach it? And actually does pretty good job at like giving you advice of like what kind of techniques or approaches or other similar problems. Obviously, they're bringing also a lot of challenges in terms of like data ownership, data privacy. It is democratizing access, but it's also making the people that really know how to use these tools even more powerful. So on one hand, it's raising the bar, but I feel like to some extent it's also making the delta much larger. So we have a lot of things to tackle and to think very carefully about.
Makes sense. And then with like, AI becoming so big, there's so many data centers that are coming up. So kind of like, what are the trade-offs? Like, obviously AI and LLMs are becoming better, but at the same time, there's so many centers that is also affecting the global climate crisis. So like, what are your opinions on like the trade-offs? Like, when do we stop, or kind of like, how do we work around that?
Yeah, a good question. I mean, data centers are popping up left and right. They're even some of them creating their own mini power plants to support them and so on. The energy consumption is a problem. Obviously, there's other sectors that are even bigger problem in terms of energy consumption. So across the board, we need to make progress on that. Like with anything related to sustainable development, I think what's important is to have this multi-pronged perspective where you're thinking about economy, society, and environment, right? So that's at the core of like the definition of sustainable development that came from the Brundtland Commission, at the very start of like the definition of sustainable development. And so right now, I feel a lot of these things are based on economy, like how much money can we get of this? And like I think it's really important to be thinking about the other two aspects, how it is impacting society, both in positive and negative ways, and how it's impacting the environment. And so I think we need to be careful. I also, the other thing I worry about is that obviously people don't understand that, for example, making like a silly query to, let's say, ChatGPT or one of the other LLMs, it's actually going to a data center, is running all of these complicated things, and where they could have done the same response with something much more lightweight or easier, right? And so as we get like very used to having like the best of the best, the cream of the crop of most complicated answer, we keep on now using this much heavier tool for even mundane tasks. And so not so much like obviously data centers, yeah, we can have them more efficient, but I think actually having some education and some kind of maybe more nuanced way of which tool we should use, as opposed to just always going to the hammer when you can solve the problem with something lighter is where we can make a difference.
Yeah, and like I was reading that like each ChatGPT query, I think weighs 17 gallons of water, or which is a lot of energy being wasted. And like you could do simple searches like on Google, or maybe even just like pick up a book and read a book. So I feel like that also like puts us a little bit behind as humans, because we're not being very intellectually stimulated. So kind of there's also that environmental aspect, like you said, but also that societal impact, as you mentioned.
Yeah, for sure. I mean, and one of the biggest thing people are, struggling with now is how the availability of these tools is going to impact education. Right? Already, my daughter is a middle schooler, and it's like almost everything that they might be asked to do at school, like ChatGPT can do very easily for you. So how do you incentivize or make sure that students are still learning and having that some of those skills about how to write well, or how to do like research and find information, as opposed to just having it like, oh, give me a summary of this book. it goes. You don't even have to read the book, right?
Yeah, it just spoon feeds you, which is not the best. And then kind of switching gears back into your core research area, which is machine learning driven combinatorial optimization. It's a mouthful there. But for listeners who might not be familiar, how would you explain that in kind of more practical terms?
Yeah, so a lot of my work is focused on like solving these really hard resource constrained decision problems. So how do we optimize some objective when we have limited resources and we have decisions to make, like buying something or not buying, creating an intervention or not creating, like upgrading a piece of infrastructure or not, etc. And so these problems are extremely hard. They're what's called NP hard problems. So they might, in the worst case, take exponential time to solve in the number of decisions you need to make. So we really need to develop better algorithms. But each kind of problem family might have its own challenges that make it harder or easier for certain algorithmic family. And so what I'm doing in my research is trying to combine machine learning, the predictive power of machine learning, with the algorithmic development that are geared towards solving these optimization problems, where it's saying, well, use the algorithm, but now within this algorithm, there's some kind of like heuristics or like, decisions that are made, and those can be actually learned from past data. So it's combining the power of machine learning to capture complex patterns from data with the still our kind of computational understanding of how to build good algorithms. For example, if you, let's say, you're trying to help UPS solve their delivery optimization problems, they have to like send out the trucks every day. They have like hundreds of, let's say, thousands of deliveries they need to make. You need to have to distribute which trucks are going to take which one and where. Doing that very quickly at the beginning of the day and also getting really good solution is hard, right? But you have to solve this problem every single day. So you have a lot of historic data of this kind of problems. You can use this historic data to train an ML model that then guides the optimization on the next days in the future. So it's kind of, I find it really exciting because it's able to allow us to find better solutions to these hard problems faster. It is also part of this kind of democratizing optimization push, because often what happens in the real world is when you get a new hard problem, you hire like specialized help, like people with a PhD in computer science or operations research, and then they kind of design a custom algorithm for you. But if you think like if you have a small company or a nonprofit or something in the public sector where they don't have the resources of the Amazons and the UPSs and the airlines of the world, they're not going to be able to do that. And so these kind of approaches can help us maybe design kind of automatically better algorithms for them by just using data from previous problems they needed to solve, and maybe alleviate the need of this like specialized consulting that's needed to solve it.
Yeah, that makes sense. And in your class, you've talked about a lot of these applications in like various fields. My group was doing research on like gentrification, and then we also read one of your, I think CAIS was a part of it, but the paper was about like choosing peer leaders in youth experiencing homelessness to reduce HIV or prevent HIV in these groups. And I think they used like an optimization approach, and it honestly made a lot of sense. So yeah, I feel like you would not expect to like use these algorithms in areas to actually help like certain problems, but you can. So yeah, that's really cool. And you've used optimizations in areas like biodiversity conservation planning. Could you walk us through how AI helps makes those kind of decisions? Like, what does the system actually optimize for? And you talked a little bit about like there's like these constraints or heuristics that you look for, but like in terms of biodiversity conservation planning, what do you exactly look for?
Yeah, so there's many different criteria that one might, consider. And so in the past, we've looked at things about how do you balance between the needs of different species, like in the wildlife corridor problem I talked about, like looking at grizzlies versus wolverine, but also you have to balance that with the economic cost of like actually realizing those conservation plans. In some of my more recent work, we're looking more in terms of climate change and what will happen to biodiversity, let's say in the next 50 or 100 years. And then you might ask questions about, are you optimizing for the biodiversity of today, or are you also optimizing for the biodiversity of the next few decades, right? And how do you like balance between how much weight do you give to conserving things as they are now versus the projections of where they might be under climate change in the future. So there's a lot of different aspects that one may want to consider. Also, another thing is thinking about, okay, the economic costs, the biodiversity impacts, but you could also add social components to it, right? A lot of conservation areas also serve local communities in terms of like providing recreational opportunities or like fishing or other things people might want to do. So you actually might integrate some of those aspects in your optimization. So it's really important to kind of, again, coming from the sustainable development principles, is to really think about the whole picture and incorporate multiple criteria and dimensions. And so back to the course on the AI for sustainable development, when the students are proposing their projects, I always try to like really emphasize that as you're defining the question or the problem you're trying to solve, is think about different perspectives and what would people care about, and try to really incorporate this possible different aspects from a social, from a cost, from an environmental perspective.
Yeah, that makes a lot of sense. And a lot of your papers explore how learning and optimization can work together. What do you think is the most exciting frontier right now in connecting these two fields?
Yeah, so in addition to actually thinking about how to leverage ML to speed up or improving algorithms, the other way that ML and optimization can really work together is actually in a lot of real world problems. Before you even get to the deciding, the optimization part, you need to predict something about the problem. Like, for example, how much need there's going to be for this thing, or what the price of this thing is going to be, or how effective a particular intervention is going to be. So you kind of have an ML component that comes before the optimization. And so one of the frontier that we are exploring is what we call this decision-focused learning, where you're learning this predictive part that comes at the start, but instead of just doing it in isolation, you could already take into account the fact that why you're learning this is because then you're going to make a set of decisions. So what you want is, you want this predictive model to give you predictions that will not fool or like misguide the decision making later. So you do that by incorporating the knowledge of the optimization straight into the training of the ML model, saying, okay, I want to predict such that when I predict these things and then I decide with them, the final outcome is a good one. So you kind of collapse that whole pipeline into a single end-to-end approach. And this can really help. For example, we have shown this how you can apply this in the context of interventions for tuberculosis. So this is like working with a nonprofit in India where TB is still a big problem. And so there, where people that have TB have to take these pills on a daily basis. And if they miss a long enough sequence of pills, actually the treatment becomes ineffective. And so they have very limited resources in terms of people that can call or go to people's houses to remind them about taking their pills. And so every day with, let's say, this crew of available people that can intervene, they have to decide, okay, how I can call at most 100 people today. Which people am I going to call? In order to solve that optimization problem, you first have to predict who is likely to not take their pill, right? And so, so what we've done is we've basically shown that if I try to like solve this problem by taking historic data, building a ML model that predicts when people will miss or not miss, and the way that they have this data is because every time people take their pill, they actually like call a number where they specify the kind of the idea of the pill they're taking, so they know when people are not taking them or taking them from the past. So if we only have an ML model that just uses historic data and predicts, okay, is a person going to miss or not miss a specific day their pill, and then do the resource allocation in terms of which people are going to be called, versus if we actually do this together. We do the prediction, but then we immediately say, with this prediction, now I'm going to allocate these 100 calls. And then with these 100 calls, I would have like successfully intervened at X people versus not, like the realization of actually who really missed their pill. When we combine them, we're able to actually improve the effectiveness by 15%. And 50% is a very big number when you're talking of like hundreds of thousands of possible patients, like being able to, have, 15% more calls that in fact prevented a missed pill by calling somebody who would have indeed missed their dose is a huge win.
Yeah.
So lots of I think there's a lot of other applications in which this happens. Like right now, we're not there yet, but right now we have a big collaboration between USC and the Center for AI and Society and AMREF Africa and the Ministry of Health in Kenya, which is focused on malnutrition among children. And AMREF is an NGO who does a lot of work in Africa around health. And so what they do is they also provide these kind of nutrition baskets that they bring to families that might be exposed to food insecurity and malnutrition. And the idea is, can we help AMREF more effectively distribute where these baskets are going, right? They have limited baskets, they have limited resources. And again, the first part is like, we need to be able to predict where is malnutrition going to spike in the next month or 3 months, and then with that, allocate the resources. So far, we have worked with them on the predictive part, where we've developed an ML model that predicts the malnutrition rates in the next 1 to 3 to 6 months. But now, hopefully, we can also extend this into taking into account this decision problem that happens after that, right? Now, based on these recommendations, these forecasts, how do I distribute the resources? And maybe then we collapse the two in this end-to-end fashion. That's one example. There's many, many more examples in which you have this kind of predict and then decide, right? And so the frontier here is, can we do the both of them together to get more effective results?
Yeah, that's very cool. I'm kind of curious to know, how do you kind of predict who's more likely to be like to have malnutrition?
So in particular, this in this modeling approach, we are not doing individual predictions. What we are looking at is more a rate of, like, let's say, in this area, in this neighborhood, in this county or sub-county, how many kids are likely to be exposed to malnutrition. Because it's more about allocating resources to a particular region, not to individual people. It becomes much harder to actually predict things on individual basis. And also the data availability is difficult, and there also has like data privacy in terms of knowing like kind of characteristics and health factors about specific people. So in this model, we're really not trying to do that. We're just looking at statistics at an area and then predicting at that same scale.
Okay, that makes a lot of sense. And in the context of sustainability, how do you think about fairness and equity? Who benefits from these systems, and how do we ensure that no one is left behind?
Yeah, that's also a very important aspect, especially exactly when working with real stakeholders, real end users. I think the first thing is, even from the get-go, to make sure that there's diverse stakeholders being represented when the problems are being like articulated and defined before even starting to kind of thinking about computational approaches. But then also, as you develop the computational approaches, incorporating metrics that look at, okay, what are some of the vulnerable subpopulations across the people that can be affected by this model or this solution, looking at how the outcomes are distributed among these different subgroups, the general population versus specific groups that represent vulnerable subpopulations. And this is really important because sometimes, first of all, the data that we is put into these models might be more representative or sampled more heavily on people that are more easily accessible, which could be people with better means. Second of all, when you're like doing modeling, let's say machine learning modeling or optimization, the objective is usually something like average accuracy or average benefit, and these averaging effects hide a lot of variability, right? So it's important to incorporate these metrics. For example, in the Center for AI in Society, one of the pillars that is very important to us is working on homelessness. And so my colleagues at CAIS, Professor Phoebe Vallanos and Professor Eric Rice, work with the LA Housing Authority in terms of trying to help them develop methods in how to allocate housing, temporary housing to homeless individuals, right? And so one thing that they really worked very hard on is how do we make these allocation systems not only be efficient in a sense that you assign you give this limited housing to people that are likely to benefit from them, in a sense it will help them exit homelessness and not go back to homelessness, which is the efficiency component, which is very good, but also looking at, well, how are these systems based on like different rules or scoring factors going to impact the distribution of that efficiency. Like, are people from different racial backgrounds equally benefiting? Like, let's say if you kind of divvy up the benefits from between white versus Black versus Latino homeless individuals, like, are these rates of improvements equally distributed? And then developing methods that are able to balance that efficiency goal with the equity goal.
That makes sense. And then if you can talk a little bit also about the homelessness research that you guys are doing, what are your main takeaways from like the past 5 years? Because LA and the area around USC suffers a lot with homelessness. So I guess like what is the research that you guys have done in that space?
I mean, so homelessness is one of those wicked problems, as they call them. Like they're so multidimensional, they're so difficult, and computational alone is very far from the solution to it. It's a very thorny social issue, but again, computational techniques can help some aspects. And so CAIS has worked on several kind of different angles of this. Like, as I said, one of them is trying to build better recommendations for housing allocations to homeless individuals. The other one is something that you mentioned, that you read about, which is how do we help places like centers which house, let's say, homeless youth to spread important public health information, for example, HIV, information about HIV and HIV prevention. And again, there's limited resources. You can only like train X number of people with that information, and then with the hope that they're going to talk to their peers, their friends, and spread that information further. So again, we've worked on approaches that can help the centers target more effectively who to involve in these trainings in order to maximize how many people hear about this key information. Some other aspects that I might be forgetting is also like even like looking at how the surveys are phrased and what kind of questions are being asked in order to make them more streamlined and more effective in capturing the data that's needed for then the other analysis after that. And many more. I'm sure there's others that I'm not thinking about.
Yeah, that makes sense. And then in terms of, there's many sustainability problems that you talked about. There's just disaster relief, poverty prediction, and it involves a lot of sensitive data. So how do you balance data-driven modeling with respect for privacy and ethical constraints? And how do you go about like choosing a data set, or like you see a data set, like how do you know, okay, like this is a data set we can end up using? So kind of how do you go about selecting data? And
so a lot of the projects that CAIS is involved in, because they're with actual stakeholders, we do also a lot of like a primary data collection, like surveys or interviews and so on. And so in all of those projects, we obviously follow very strict like ethical protocols, and any study that involves humans requires what's called an IRB approval, where you can very explicitly have to like define exactly how you're going to select who to be part of the study, what kind of protocol you're going to follow while interacting with them, and how you're going to protect their data from leaking out or misuses. So that's one. In terms of using already available data sources, again, one has to be very careful in terms of like reading the small print, making sure that this was collected in an appropriate way, etc. But data privacy is a big issue. Anytime that you're doing something that involves individual human intervention, like for example with the homelessness, um, some other projects that we are working on. I have a collaboration with CAIS Permanente, where we're looking at trying to predict substance use among youth, among like people from 12 to 17 years old. And that again is based on electronic health records, for example, which is like very sensitive topic. And we have very, very strict protocols about like how to anonymize the data. So for example, before the data even comes to USC to do the analytical part, the Kaiser team has like a whole bunch of steps that they follow to de-anonymize it, so that there's nothing about their patients that may
Yeah. No, that makes sense. I worked on a health tech startup like last semester, and we basically wanted to automate data entry into EMR systems to kind of give the nurses more time to actually look after the patient instead of spending hours at the front desk entering this information into their EMR systems. And I think through that process, I realized that there's so many like legal kind of barriers, or not barriers, but like data privacy concerns that we need to take into account. There's the HIPAA compliancy
Yes.
act. So there's a lot of things that you need to think about when it comes to data. But I think there is a lot of ways that you can, like you said, reading the fine print, ensuring that for example, like in our use case, we needed to parse the data using an LLM, or give the LLM the data so it could automate the data entry into the EMR system, so that you can like, if you could sign a license with Claude to ensure that the data is private, etc. But yeah, that makes sense with what you said. And then in terms of like giving advice to our audience, or just students who want to pursue socially impactful AI research, but they don't know where to start, what advice would you give them? And this could kind of be also like personal to like how you got started, maybe like reaching out to more people, or
Yeah. I think the key thing is to like really keep an open mind and come into it with kind of the idea of actually really trying to make the social impact. I think one of the things that's important is not to be like, oh, I just want to find an interesting problem to work on. I think that's the wrong attitude. You have to go in thinking like, I'm interested in really understanding this complex, messy real world problem, and to design something that would like turn back and help them. But in terms of actually getting started is, looking very much in terms of who is working on this kind of problems, going to some of these publication venues that I mentioned that have like papers that are really focused and kind of already curated in one place in terms of AI applications to social good is a good start, just to even get a sense of like what's doable, or what are the domains that are very like ripe for computational approaches is good. When finding an opportunity, sticking with it. Also, like in terms of, let's say, undergraduate involvement, what I find is a lot of undergrads like come in and they're like, oh, I'm going to try this for a semester. Oh, now I want to do this other thing. And I think if you want to really make an impact, you have to have that like perseverance. It's like, okay, this is going slow. It doesn't look like it's making a big difference. Instead of like jumping ship, is like actually staying the course and being there for 1-2 years in order to see it really come together. Because again, these problems and these applications are complex. they involve interdisciplinary teams, so things take slower and so on. But if there's like this real passion and commitment, then good things can happen.
Yeah. And then in terms of your AI for Sustainable class, what do you think is your favorite part about teaching the class?
What's my favorite part is the projects. So the students have to come up with, a project for a team of 3 to 4 people that is focused on some kind of sustainability application. And, going through that process of like, oh, what does it mean to define an application domain? But then also, then does this question even make sense? Is there the data to address it? And like actually guiding the students through that process is always super exciting to me, also because I believe this is a skill set that they may actually take and use in the real world after they graduate to do more, social good and sustainable development applications of their AI skills. So definitely that. And it's always impressive every semester how the students in each class come with completely new topics. Like every time there's like new domains, and I like the creativity is always very impressive. And like the spread from like thinking about education, some people being excited about health, other people being excited about the environment, or like fast fashion, or like it just also teaches me so much about stuff that I might not have seen so far. So I really love it.
Yeah, that's really awesome. And just like a final question that I have here is, what's a misconception about AI for social good that you wish more people understood?
What's a misconception? I mean, there could be several misconceptions. First of all, I think a lot of people underestimate about kind of how messy it is and how long it takes, especially inexperienced people coming from the computational world where they're maybe like more used to having lots of data available and very clean defined metrics of success. And a lot of these problems are actually really kind of ill-defined and require a lot of like back and forth in order to refine them. They also have usually little data. And so in fact, like, now with, LLMs and big AI, a lot of the, the excitement is about this kind of really data-rich systems. But a lot of the social impact applications actually involve areas where we don't have a lot of data. So what's called like small data machine learning or small data problems. And so I think that's that this misconception about like, oh, I'm going to come in and they're going to have all this clean data or well-defined problems, plus lots of it, is like usually almost never the case. And then the other big misconception is like underestimating of how difficult the last mile of this project is. Let's say you've gone through this process of defining the problem, finding the data, developing the technique, but then taking that and packaging it into something that, the NGO you're working with can use is also a very big lift, because again, you cannot give them like, oh, take this from the GitHub and run it on your terminal.
Yeah.
Again, these are not computational people. So coming up with that last mile of like, how do you put this into a usable tool that is, speaks their language in terms of how it's presented, it's easy to use, etc., is also daunting. And what happens is actually that's where a lot of AI for social good projects fail. They run out of steam, or it's not as exciting, so they don't do this last mile. And what happens is that, you like have something on your CV or a paper, but it actually doesn't get into the hands of, the people that need it. And it doesn't have that real world impact that you might have meant from the start.
Yeah, that makes sense. Going that last mile is, I think, always, it is the hardest part, but at the end of the day, the whole reason that you did the first few steps was to be able to, make some impact, actually solve a pain point. But in terms of like getting data, like you said, it's very messy. It takes a lot of time to get that data. So when you like work with communities, if you do, kind of how do you develop trust within these communities when you're collecting data?
Yeah, as I said, I haven't done a lot of work with direct data collection, but even getting like communities or stakeholders to share data that they might already have with you is, yeah, it's quite a process. You usually like have to develop a report where like we maybe have a lot of meetings in which we brainstorm. They tell us like what the problem is. We pitch back like, oh, how we might go about solving it or what they might expect from, maybe the proposed methodology or tool to do for them. They have to see the benefit, and maybe you might even sometimes have to like build a prototype which is with surrogate data that's not their data or that's not the sensitive data to get, because sometimes it's actually hard to communicate just with words what it would look like. So you might need something that actually looks like the real thing. So that's at least my process of just, investing that time to develop a common language and common understanding of what the benefits could be.
Yeah, that makes sense. So I think that's all the questions I have. But yeah, thank you so much for coming onto the podcast and sharing your insights. I'm sure our audience and I myself found it really, really interesting. So thank you so much.
Thank you. Thank you for having me.
Of course.